Okay, so this video is going to go over your work for today, Wednesday, January 5th. So please pay attention to this slide. I am giving you specific problems to do in your workbook today. Feel free to do more if you have more time, but I took away some of the problems that had adding and subtracting fractions just because that's kind of annoying. Also, please notice that your exit ticket, which is number 4, it's going to post in Google Classroom before the end of class. You won't see it right now, but you'll see it before class ends. So today we're doing Module 4, Lesson 6. So you are going to be solving equations, but first you're going to have to transform the equations into simpler forms. So you have to simplify them first using the distributive property, which is what you did on Monday. And then you're going to solve, which is some practice that you did yesterday. Today, we're also going to add in that you're going to learn not every linear equation is going to have a solution. So we're going to practice 2 problems right now. These problems are not in your workbook, but you should definitely follow along. If you want to pause right now, write down the problem and try it on your own, see if we come up with the same answer, that's perfectly fine. And that's a really, really good way to get some practice in. So remember I said first we are going to have to simplify these problems, right? We see some parentheses here. Inside of the parentheses on both sides, we have a variable with a coefficient being added to a constant. So we cannot add these. I still am seeing some people making those errors and telling me that 7x plus 3 is 10x. It's not. So please don't do that. You cannot add terms that are not alike, but we can multiply, right? So I'm going to start by simplifying this. Right now, there's nothing I can do with this 4x. So I'm just going to rewrite it as it is. But I can distribute this 3 into both terms inside the parentheses. It's a positive 3, and 3 times 4x would give me 12x. I can also multiply this 3 by the 7. Don't forget that, right? Both terms inside of the parentheses do have to be multiplied by the 3. They're both positive numbers, so positive times a positive is positive, and 3 times 7 is 21. Now for the right side of my equation, I'm going to start right away with the distributive property, distributing this 4 into both terms inside of the parentheses. 4 times 7x would be 28x. Sorry, this is getting a little messy here. And 4 times 3 is, of course, 12. This 4 is not being multiplied by this constant. It's outside of the parentheses, so I can just add that on to the end. Okay, so it's always a good time to go ahead, and check your work. Make sure that you didn't make any errors in multiplication. Definitely double check me. Not feeling great, so my brain is not working perfectly. So I'm hoping as I go, I'm not making any errors. But if I do, hopefully I'll find them, see them early on, and fix them. I'm just going to change my color so you can see I'm doing another line. The next thing I'm going to do is I have a lot of x's, I have a lot of constants, so I'm going to go ahead and go through and combine my like terms, right? On this side of the equation, I can add these two x's. I can add 4x and 12x to give me 16x. I cannot add it to the 21. So my plus 21 is just going to stay plus 21. On the right side of the equal sign, I can combine these two like terms, right? The 12 and 3, they don't have an x, so I can combine them. I cannot combine them with my 28x, so I'm just rewriting that. And 12 minus 3 is, of course, 9. And it's a positive 9, so I'm just putting plus 9. Now I can start solving the equation, which is what we practiced yesterday. Remember, my goal is to get x alone, right? I want my answer down here to look like x equals some number. You'll notice I do have an x on both sides, right, of my equal sign. I have a 16x over here, and I have a 28x over here. I want all of my x's to be on one side of the equal sign. And I just move it, right? I just do the opposite operation. These are both positive numbers. So the opposite would be subtraction. It doesn't matter if I say, okay, I want to subtract 28x over here, subtract 28x over here, or if I subtract 16x, right? It doesn't matter. You'll come up with the same answer in the end. I tend to try to make myself get as few negative numbers as possible. So because 16 is smaller than 28, I know if I subtract 16 from 28, I'm going to end up with a positive number. So that's what I'm going to choose to do. But again, you can do whatever you want. So I am going to subtract 16x from both sides of my equation, remembering that I cannot subtract terms that are not alike. Right, so on this side, the 16x will cancel out. I'm left with just 21 equals 28x minus 16x. What is that, 12x? Right, 28 minus 16. 16, 26, yeah. And then my plus 9, I didn't do anything with that yet. All right, looking good so far. Hopefully I haven't made any errors. 28x minus 16, yep, 12. Okay. All right, now I still want to get my x alone. So I'm looking at the side of my equation that has the x on it. I'm just switching colors just so that you guys see each of my steps. So I still want to get this x alone, right? Just like we practiced yesterday, in order to do that, first you're going to undo the addition or subtraction. So first I'm going to choose to undo this 9. Since it's adding, I'm going to do the opposite. Okay. So on this side, I should be left with 21 minus 9, which is 12. And over here, I'm left with 12x. So now I have 12 equals 12x. I'm still following the same steps. So yesterday, after we undid that addition or subtraction, right, I still want to get this x alone. Oops, I'm not going to use yellow. It's hard to see. So I want to get this x alone. Since 12x means 12 divided, or excuse me, 12 multiplied by x, 12 times x, I need to do the opposite, which is division. So I'm going to divide both sides by 12. Oops, I have eraser on. I'm just going to divide this side by 12. And I'm going to divide this side by 12. So on this side of the equal sign, 12 divided by 12 is 1 equals, and 12x divided by 12 is 1x, or we just write x. Okay, so my solution here is x equals 1 or 1 equals x. And keep in mind, I can go back up to my original equation, and I can put in 1 for each of these x's and then solve, and I will come out showing that these two sides are equal. So it is a good idea to double check your work. We'll definitely do a lot of practice with that when I return, for sure. It's just hard for me to write using the mouse. So, but you can definitely go back through and instead of writing x, write a 1 and double check this solution. Okay, so here we have a solution. It's x equals 1. We had to do several things first. We started with getting rid of the parentheses. Then we simplified, and then we started solving just like you guys were practicing yesterday. So that was example 1. Example 2. Let me try to switch slides. Okay. So example 2, let me change this. I should say example 2. So you guys will see that it's a different problem. So example 2 is also not in your workbook, but I just want to show you a different type of, we're going to follow the same steps, but you'll see in the end that this one's a little bit different. So let me just erase everything from example 1. Again, if you want to pause and try this one on your own, you can. All right. So let's see, example 2. Same thing, we're finding the value of x that's going to make this equation true. I have one set of parentheses here, so I want to start by simplifying, and I'm going to distribute this 2 inside the parentheses, multiplying it by both terms inside the parentheses. 2 times x is 2x, and 2 times 1 is 2. Since these are both positive, it is a positive 2, so I can write plus 2. And on the other side of my equation, on the right side, I don't have any parentheses, so I'm just going to go ahead and rewrite. Just like in example 1, I now have x's on both sides of my equal sign, so I want to move those to the opposite side, right? Or move the constants to the opposite side. It doesn't matter what you do first in this case, as long as you're following the rules of algebra. So in the last example, I moved the coefficient and the x first. But in this example, I will go ahead and just move the constants first, just for a little something different. But again, it doesn't matter what I decide to move first. So I'm going to choose to move this plus 2 over to this side. So remember, I'm always doing the opposite operation. So since this is addition, I'm going to subtract 2 from both sides. On this side of the equation, this cancels out, leaving me with 2x. And -3 or -3, -3 minus 2 is -5. Okay. Remember, because this, I'm saying this is -3, which sometimes confuses a lot of you, but I could say 2x minus 3 is the same thing as saying 2x plus a -3. We can't ignore that subtraction sign. It does have to stay. So I call it a -3 minus 2, giving me the -5. Again, I want all my x's on one side of the equal sign. So I'm going to go ahead and move this over to here, right? So on one side of the equal sign, I'll have my x's, and on the other side, I'll have everything else. So since this is a positive 2x, I'm going to subtract 2x from this side, and I'm going to subtract 2x from this side. Well, now that leaves me with a problem, correct? Because if I do this, 2x minus 2x, well, over here, that cancels out. It also cancels out over here, which might look like something like 0 equals -5. But does 0 equal -5? Of course not. So here we would say there is no solution. So this is an instance where there is no solution to this equation. I could have done it differently. Some of you that might have paused the video might have done steps a little bit differently. You would have still distributed first to get what I got here in the orange, which was 2x plus 2 equals 2x minus 3. If in the last problem, you decided to move the x first, which is the step I did second in green over here, if you decided to move the x first, I get rid of that 2x on this side, which means I have to subtract it on this side. Well, what happens? It cancels out the 2x over here. It cancels out the 2x over here, and I'm left with 2 equals -3. Does 2 equal -3? Of course not. So again, it doesn't matter which order I do this in, but in both cases, I find that there is no solution to this example. So in some of your workbook problems today, you might have some where this is going to happen, where you're going to find that there is no solution. So you can go ahead and do the work like I've done here, and your last entry, just like I've done. I'll circle it in red, hold on, maybe with a bigger. I should see something like this, or I said I was gonna circle it in red, that's green. Right, maybe I'll see something like this where you did the work, you came out with something that didn't work. Instead of writing an equal sign, make sure you're writing a symbol that looks like this, an equal sign, but a line through it, that means not equal. And then you can also write and tell me that there is no solution. Definitely let me know if you guys have questions as you're working. I have been trying to check Google Classroom and my email and questions throughout the day. So definitely let me know if you have questions. All right, so let me go ahead and erase this and get to the next slide. Clear those annotations. Get to the next slide here for you. So again, your exit, you have to do the workbook pages, pay attention to the problems that I told you to do. And then again, your exit ticket will post towards the end of class. Check the last 20 minutes or so is when your exit ticket should post and be available to you in Google Classroom. If you have any questions, let me know.